Hi, this is Tom Reardon, math teacher from Ohio. I want to show you how to use TI-Nspire CX activities in the mathematics classroom. The first one we want to look at is whether something is a function or not. A standard activity in an algebra class would be given the graph of a relation, determine if it is the graph of a function. And the way I've done it for years, and you probably have done it, is the vertical line test. Take a ruler or meter stick and say, if this vertical line intersects the graph in more than one part, it's not a function. And so you can see that the blue one passes the vertical line test and is a function, and the red one does not. And we were kind of happy with those results. But with technology, this is an activity that is on this TI-Nspire CX handheld. It's available online. I'll tell you how to get that for free in a minute. Let me go to that. This is a TI-Nspire CX handheld emulator that is going to emulate what the student would be doing on his or her own individual handheld. Okay, now I'm going to be using a smartboard and using touch features, but that's not available on the handheld, but you'll be able to see what the student will be able to do. So here's the activity, function or not a function. On the next page, drag point P and to see the number of times the vertical line intersects each graph. So going on to the next page, this is what the student would see. The student, using the mouse on the handheld, would grab point P and move it. I'm going to use my finger here to do that. So grab point P, and you can see that on the first one, the top one, it is a function. It only intersects the graph in one point, whereas with the bottom one, it intersects in 3 points. But what we didn't share enough with our students is the fact that with the same x-coordinate, we got very different y-coordinates, and that's what makes it not a function. Not so much this vertical line idea, but the fact that each first coordinate can only have one unique second coordinate. And I think this just takes care of that in a much better way, also more thorough, and again, each student's discovering this at his or her own pace. The second activity I would like to look at is, do you teach students how to obtain the domain and range from a graph? And are you successful at it? Now, I'm hoping you are, but I know that's a really tough thing to teach kids. And so one of the, next activity will help us look at that. And this one is called domain and range. It says we're going to use graphs to investigate domain and range. So moving on to the next slide. Here's given a graph of a segment, and a standard activity would be, what is the domain and range of that particular segment? One of the, and students have a lot of difficulty with this. I know a lot of them will just give up and say, oh, all real numbers, and that's a real common answer, but that's not the right answer here, of course. So one of the things I've used is something called the flashlight technique, is where I tell my students, imagine holding a flashlight above the graph, and wherever the shadow would be on the x-axis would be part of the domain, and then put a flashlight below the graph, and wherever the shadow would be on the x-axis would be the rest of the domain. So whoever created this activity must have known that idea about the flashlight technique. So the student's going to be asked to grab point P and move it along the graph here, and watch what happens. So grab point P and move it, and you can see that the domain and range, the shadows, are being recorded in blue and red. The domain in blue and the range in red. And now the student has a better idea of visualizing what we meant by the shadows, what the domain is, and that sort of thing. On the next page of this document, they're asked, what is the domain and range? How would you write that with the proper math notation? And so if they click on this, they can see whether or not they actually did do it correctly with all the proper notation. Second example, here we have another graph with a little bit unusual situation going there, okay? And so again, the student would be asked to grab point P and move it along to be able to visualize the domain and range better. So I'm going to go ahead and use my finger. They would be using their mouse to grab point P and move it along the graph. And the blue again is the domain and the red is the range. And it's pretty obvious that the domain is all real numbers in blue, and the range is between -1 and 3 inclusive. But again, to make sure, the next page asks that question, and they have to interact with this to be able to see what the actual answer is. The third example is one of my favorites, part of a parabola. And it has a little subtlety in it that I'm sure many of you recognize, okay? I'm going to go ahead and grab point P again and move it along here and pull it all the way up there and pull it all the way down. And the subtlety that you probably noticed is the domain has an open circle, whereas the range has a closed circle. And those of you who teach Algebra 2 and pre-calculus know that that's the key idea of whether or not that function's defined at that point or not. And on the next page, it does show the proper notation of showing the domain and range. And it is color-coded so that students can make those associations. The last part of this activity I think is just amazing. Normally, we're given the graph, asked for the domain and range. This one says, here's the domain and range, create the graph to fill that need. And always going backwards is a good idea to kind of get students to really understand the concept. So here we want the domain, which was in blue here. We want the range, it's in red here. And so the student can grab these things and move them using the mouse on the handheld. I'm going to use my finger. And the domain looks like it starts at -3 open circle. The y-coordinate is 2 with an open circle, so I'll grab the open circle, -3, 2. And it's going to end up at 7, -5 with a closed circle. So grab that 7, -5. And that seems to satisfy the requirements that we wanted. But on the next page, the students will be shown whether or not they're correct. And this, to me, is just an amazing activity. The students are working at their own pace and doing their own individual work. Now, going back, how do you get these, or where do you get these particular activities that are for free? It's TI-Nspire.com. And not only do you get the TNS files, the TI-Nspire files, but you also get the student worksheets and the teacher notes and solutions. Those are all part of it. You can get the whole package, you can just get the TNS file, whatever. I hope you enjoyed our video, and thank you for watching.